Hello, and welcome to the Subby Zone, Episode 6, Factoring Polynomials Using Factoring and Through Quadratic Form. I am your host, Phil Subby. Okay. A quick update about last week. I don't know if the people following me are real. They possibly could be a hallucination. I'm not 100% about any of it or anything. So, grouping, okay? So I'm going to put an example, and we're going to group it to factor it. And again, factoring, just not again, but for the first time I'm telling you, is factoring is useful so you can solve, eventually, we're not going to solve them now, these polynomials, and find the roots of the polynomials so you understand what values of x will make it 0. The y-intercepts, if you like. When y equals 0, what is x? That's what you would find. So let's start this up. So what you're going to have is you're going to have a number times a parentheses plus another number times the parentheses, and the two parentheses are going to be equivalent, and then that way you can group. So let's go into it. So what's the biggest number that can go into x to the third plus x squared, or x cubed plus x squared? And that would be x squared, okay? So that would be x plus 1. Now if you look at this, so you've got x squared times x, it would be x to the third plus x squared. So it's equivalent. Now what's the biggest number that can go into x plus 1? Add it. That would be 1. Now you can put a 1, or you can just leave it blank, okay? Because that 1 is implied. So you got x squared plus 1 times x plus 1 times x plus 1. Now you can group it. So x squared plus 1. I'm going to put that 1 here so it's not confusing. These things are equivalent, okay? Plus, or no, times, right, times x plus 1. Because these parentheses are equivalent, so you can group them together. Now let's make sure we're right. Let's check our work using multiplying polynomials like we did the other week. Okay, so x squared times x plus times, so this is going to be distributive property, and then 1 times, there you go, okay? So that would be x to the third plus x squared plus x plus 1. Are they equivalent? X to the third, yes. These two are equivalent, and so this works for factoring. Now later on, maybe the next video or the video after that, I haven't decided yet, we'll find out, how to get the roots using these parentheses. Okay, so let's move on. So I think I might be hallucinating people, because what will happen is I will not see someone. And I go to school with 30,000 students, and I'll think about somebody, and I won't see them, for a while, and I'll think about them like the day before, and all of a sudden they'll pop up. And sometimes they'll say in conversation things that I have done, like alone, and that they would have no idea about, and for some reason they know about. Okay, so again, what is, going back to grouping, what's the biggest number we can go into these? I can't do 3 because this is just x squared, so it would just be an x squared. So x squared is x plus 3. What's the biggest? This would be 10, goes into both. Now, here's another thing you want to look for. So that would be x plus 3. You have to equivalent. You have to, this parentheses here, and this one inside the parentheses. It has to be equivalent for grouping. So if you get an x plus 3, we have to look at both these sides, and these sides. And look, this is going to be obviously x plus 3, because there's that 10, and it goes into, 10 is going to go into 30, That's the biggest number to go. So, you kind of know it's going to be x plus 3. So you're trying to figure out one that could go into both. Because I could take an x out, and that'll be x squared plus 3x. That's not going to be equivalent to x plus 3. Okay? And we group it together. And let's check our work. You don't have to do this every time, but this is just good practice. X to the third plus 3x squared, these two, and then plus 10x plus 30. You can see that is equivalent. So the grouping works. Okay. All right, and now we're on to quadratic. So what I really think is that the CIA or some kind of governmental agency is in charge of what's happening. That people see me at school talking to air, but they are told they can't speak to me about those things, and they're studying me because I'm a very special case when this happens. Usually, if this happens to the kind of person, they can't graduate school, they can't think logically, and so they're studying me in that way. That's kind of where I'm at. I'm not 100%. Okay, so 16x to the fourth minus 1. A good way to look at this is when you have, this looks like a perfect square, right? It's very similar. So you have a 4x squared, right? That's going to be equal to 16x to the fourth. So you can see that that's going to work out, and you know that with a negative 1, if these numbers are equivalent, the first two, the 4x squared, the 4x squared, if these are equivalent, if you times this by negative 1 and now positive 1, or whatever, negative 2 times a positive 2, then that middle exponent, that middle x, is going to subtract out. Let me show you what I mean. So you got that works, and then this one's going to be, to get negative 1, you got minus 1 times plus 1, or vice versa. Now let's work this out. So it's going to be 16x squared plus 4x squared minus 4x squared minus 1. As you can see, these cancel out, right? Plus 4x squared minus 4x squared equals 0. It's going to become 16x squared minus 1. See how that works? See how that grouping works? And again, we can use these to get roots, these parentheses. I'm going to do one more example. 32x to the 6th. I don't know a real good way about this one, but I kind of go with plug and chug. You know what I mean? That's what I like to do. It just means just plug in some numbers, see if it works, see what works, and substitute where you need to see fit. So 32, well, some numbers that go into 32, some factors of 32, and 8 and 4. That's probably where you're going to be. Yeah, let's try that one. 8. So we can do 8x. Well, let's do 8x to the third. It's 4x to the third. Now negative 2, factors of those 2 and 1, right? So those whole number factors. And so let's just do a minus 2x and then a plus x. Okay? And let's just see if this works. And I don't think it's going to work, but let's see. So this would be 32x to the 6, which is right. And this would be, I'll write it out for you. This will be plus 8x to the 4th, and then this will be minus 8x to a fifth because, oh, what? Oh, wait a second. 8x, yeah, that works. 8x to the fourth, and this will be negative 2x squared. And see, that works, right? These cancel out. And we get 32x to the 6 minus 2x squared. Okay. See, that one works. There's another way we can do it too. Let's do 8x to the 4th minus 2x squared plus 4x squared plus 1. Let's see if that works. So that would be your 32x to the 6th plus 8x to the 4th minus 8x to the 4th minus 2x squared. As you can see, these cancel out, and that's going to also give you that, right? And really, this one works, and this, these both work. Is watch, if you take a 2 out of this, 2x out, it's going to become 4x squared minus 1, right? Now you take a negative, if you take a 2 out of this, a 2x squared out of this, this is going to become a 4x squared minus 1. See how they become equivalent after you take out a 2. So again, you're going to come up with the same numbers for your x's to make y equal 0. Okay, and that's it for today. And what I'm gonna do about whatever government agency or whatever is going on is I'm gonna keep trying different things to push out answers. So the people I suspect of not being real, I'm gonna say things to them to prove they are not real. See you next week. I love you.